The memcpy function C copies data from a source to a destination. Memcpy is in the string.h header file, so we will hash include string.h. We will also want to print our answer out, so we will hash include stdio.h. We are working with arrays today, so let's give ourselves a constant length variable to work with. Const size t len equals 5. If you're not familiar with size t, it is similar to an int, but doesn't store negative numbers. Next, we'll give ourselves a destination array. Int dest array of size len. After that, we will give ourselves a source array that holds 1 through 5. So, int source array equals an array containing 1, 2, 3, 4, and 5. Next, let's use memcpy. So, memcpy dest source len times size of int. What this call means is start copying to dest source and copy over len times the size of an int number of bytes. In this case, that would mean copy over 20 bytes, assuming a 4-byte integer. Next, let's print out dest. If you didn't know, C is no built-in way to just print an array, so we will have to print it with a loop. For int I equals 0, I less than len, I plus plus. Inside the loop, we will printf double quotes %d \n, then printf the item at the particular index in dest. And that's our code. If we run the code, you'll see it prints out 1 through 5, each on their own line. You aren't just limited to copying over full arrays though, you can copy just slices of an array. Let's delete the memcpy line for now to change it. Memcpy dest source plus 1 3 times size of int. What this says is copy to dest the data starting 1 integer into the source array and only copy over 3 integers, which, if you follow that, should mean that destination now contains 2, 3, and 4. To get this outcome, we'll have to slightly change the loop, because we no longer need to loop over the entire length of source. So let's change the stop condition on the loop to be I less than 3. If we now run this code, you'll see 2, 3, and 4 printed out. One final note, you'll probably notice that memcpy is very similar, if not identical, to strcpy. So when do you use strcpy over memcpy? If you're using strings, use strcpy. With anything else, you should use memcpy. In C, memset sets a portion of memory to a given 1-byte value, byte by byte. Memset is in the string.h header file, so we will hash include string.h. We will want to print our answer, so we will also hash include stdio.h. We can use memset to initialize an array to all zeros. Let's give ourselves an array that holds 10 ints. So, int x array of 10. Next, let's set all 10 slots to 0. So, memset x 0 10 times size of int. The first argument is the location or memory address to start assigning values to. The second argument is the 1-byte value you are assigning. Finally, the third argument is how many bytes to assign to. Now, let's print out the array. For int I equals 0, I less than 10, I plus plus. Inside the loop, we will do printf double quotes %d for ints \n, then printf the item at the current index in the array. If we run this code, we'll see 10 zeros printed out. Now, We could change this to work for any number, right? So if we change this 0 in memset to a 1, that'll fill the array with 1s, correct? Let's run the code and see. Huh? Those are definitely not 1s. So what's up? It turns out, if you convert this number to binary, it's basically like every 8 bits in a 32-bit integer being set to a bit pattern that equals 1. In other words, memset cannot be used in a general sense to initialize an array with all of a given integer. Memset only works on a byte-by-byte basis. Wait, so how did zeros work then? That part is simple. 0 is 0, no matter how many bits you are working with. Now, let's do one last example that will actually work as expected. Let's change x to a char array. Then we will set the first 5 characters to s. So, memset of x, character s, and just 5, because chars are defined to be only a single byte. Then we will assign the next 5 characters to t. The first argument is the memory address to start assigning to, so memset of x plus 5, character t, and again, just 5. Finally, we will change the format specifier to be for characters, so change the %d to a %c. If we run the code, we'll see 5 s's followed by 5 t's. This has been Jacubication. Like and subscribe to learn more.